Hey folks, so in this video we're going to introduce the search problem. So the search problem is going to be the first kind of archetypal graph problem we try to solve. So what is the search problem? So imagine that you have some graph, for example what I have drawn up here, and you want to ask the following question: are two vertices connected, right? So that's the problem we're going to try and answer, right? More specifically even, what we'll say is, given some start node, right, and this start node we can pick whatever it is it connected to some other node, right? So it's like, somehow we're answering the question that maybe there's a really important node, are you connected to a bunch of other things or not, right? So that's what we'll try to do. That particular node that we're going to be looking at, we'll call it S in code. It also stands for start. So yeah, this is our basic problem. So we are going to define an API here, but it's not really all that important, not necessary. It's a little bit overkill, but just for the sake of being consistent, and maybe at the end of the day, right, we can show all the different things fit together, we'll stay with the API. So what does the API look like? The API looks like this. So I have my interface search, right, whatever. I have a constructor. My constructor takes a graph and S, right? So all of a sudden, right, so what this is, right, this is an ADT or an API that basically is encapsulating an algorithm, right? So we're not talking about algorithm yet. We're talking about a problem that is typical for graph data structures that we might want to solve, right? Because once we define it like this, we'll basically have different algorithms that we can use to implement this, right? So this is our problem, our formalization of the problem, right? And then we try to figure out, how do I solve it? So starting for now, right, I just have this API here. My constructor takes in the graph, right, which is the data structures we implemented in the previous videos, and then a starting place, right? So this is the first thing you want to check, right? Is this thing connected to this other thing, right? So this first thing is called S, right? That's kind of the initialization step. And this is actually where our algorithm will live, because it'll go and it'll say, oh, as soon as the constructor is run, it'll go and figure out what's connected to what, right? So this is going to be our starting point. The second thing here, right, is marked. So marked is basically a method where you check to see, oh, did something get marked? What does that mean? Basically, right, what this is saying is a node is marked if you were able to reach it from the starting position, right? So when I initialized this thing, I gave it a value for S, which is some node in the graph. Was I able to get from that node to this other node, right? So if marked is true, that implies that S is connected to V. If marked returns false, that implies that V was not connected to S, right? So S should basically go and we should try to get from S to everything else, right? And then mark it, right? Because that solves our problem, right? That solves our problem checking to see whether two things are related or not, or two things are connected or not, right? We're starting someplace, just going everywhere you can reach from there, and then once we've done that, right, we'll kind of write that down, right? Write down, and mark everything that it touched, and then later we can ask the question: did it touch this one thing? Did it get that far, right? Did it get to V or not? And so that's what that second algorithm, that second method is basically given. So it's checking to see were you able to reach it, given that you started somewhere. The last thing, of course, is count, which is basically giving us the number of things we were able to mark or number of things we were able to touch, starting at S. All right, so that's our basic API. So let's take a look at a graph and maybe try to see how this would give us some answers here. So let's say, so we have this graph here, so 0, 1, 2, 3, 4, right? And this is a graph which has a little bit of a problem because not everything's connected, but that is what it is. So over here, right, notice our first line, we go S equal new search G of 0. Basically what you're saying is, I want to search this graph to see whether things are connected. I'm going to start at node 0. What is node 0 connected to, right? That's what this first line is doing. And then I go S.count equals 3. What that's saying is, starting at 0, you were able to get to 3 nodes. Okay, sounds legit. Then I can go S.marked at 4, returns true because, oh, hey, I was able to reach from 0 to 4, right? So somehow in here, right, these things are going to be marked, right? Those things should be marked because they're reachable from that start node 0. Okay, so those things we can hopefully get to. Now let's look at the last line. S.marked2 is equal to F. Basically what that's saying is, so is that node 2 marked or not? Problem is here it's not, right? It's false. So that node doesn't exist, right? Well, well, I shouldn't say it doesn't exist. It does exist, but I can't reach it, right? So there is no edge, right, that can take me from 0, 1, 3, or 4 to 2. There's no way to get there. So that's kind of an issue for me. And I don't mark it. I just have to return false, and that's basically indicating to me that I have a disconnected graph, right, where I can't get from one side to another. So that's using our API, right? And you can imagine, right, you do all sorts of stuff here, right? You could, well, I should say that. So you can imagine here, you could have all sorts of different scenarios behind the scenes. So for example, right, I could have these be, people that basically represents that all these, one knows these 3 people, but then 2 doesn't know anybody, right? So you're asking the question, does somebody know somebody else, right? That's what this algorithm will solve. or if these are classes, no edge, no path would imply that there is no prerequisite chain between these two different classes, right? So depending on the different problem you put in, you could be getting different answers out. So we're going to start with this basically as our first example of a graph problem, right? We're writing an algorithm to solve it, and then we'll kind of iterate over time and get kind of more complicated and more complicated algorithms. But for now, this is going to be our starting place, right? We want to be able to solve this problem. Starting from a particular node, can I get to some other node, right? This is my initial problem. So we'll take a look at that in more detail in the next couple of videos as we actually invent an algorithm to deal with it, something called depth first search.